Good morning, all of you. Today we are going to discuss about the tangents and secants to a circle. So, first of all, what is tangent? What is secant? Say now. What is tangent? What is secant? Suppose this is a circle. Okay, na? This is a circle. This is the center of the circle. Suppose here I can draw a line as like this. See, once you see this line touches the circle. Yes, no, it never be touches. Suppose here I can draw a circle as like this. Yes, it touches the circle. Yes or no? That line is touches the circle. So at in how many points the line touches the circle at only one point. At only one point. That line only called the tangent. That line is called tangent. So what is tangent? All are you know what is tangent? A line touches the circle at one point. Keep it in your mind. A line touches the circle at one point. A line touches the circle at one point. Okay, na? That line is called tangent. That line is called tangent. One more question koda they are asking in the examination. For one more question, what is tangent? So you simply can write a line touches the circle at one point is called the tangent. Now what about this point? That point is called point of contact. That point is called point of contact. Keep it in mind, the point of contact. Okay, this is called the tangent. Now what about secant? What about secant? Suppose here in this circle I can draw a line as like this. It touches the circle at 2 points. It touches the circle at 2 points. Okay, means a line intersects the circle at 2 points. So that line is called what? That line is called secant. That line is called secant. I hope I understood. So what is the difference between tangent and secant? He asked for one more question. What is the difference between tangent and secant? Okay, so you can simply write it. A line touches the circle at one point. That is called the tangent. A line intersects the circle at 2 points is called the secant. In examinations, they ask as like this: what is the difference between a tangent and a secant? Simply you can write as like this. This is asked for the 2 mark questions or 1 mark questions. Now we can discuss about that another point. So that is, suppose I can take one circle and I can take one tangent as like this. I can take one tangent. So now this tangent name is xy. Now that tangent x here, xy is a tangent to a circle with center O. Suppose I can take the center O. Okay, na? Right. Now the point of contact here can be denoted as A. So with the center O at point of contact A. Point of contact A. Now join OA. Join OA. Join OA. So what is OA? OA is nothing but here radius of the circle. OA is nothing but the radius of the circle. Now this is all is that what given information. This is the given information. Now once you listen, suppose here I can take three more points as like this, except A. I can take so more points B, C, D, A. Tangents, the points on the tangent except A nanna, except A, remaining all the points are more distance from O. Suppose here I can join OB or otherwise OD. Okay, OP. So OP is more than OA. Suppose I can join OC. OC is more than OA. OB is more than OA. OD is more than OA, and OE is more than OA. As like the points on the tangent except A are more distance from center of the circle, from center of the circle means, so therefore, so OA is the shortest distance. OA is the shortest distance compared to the remaining. OA is only the shortest distance. Therefore OA is perpendicular to the tangent. OA is only the perpendicular to tangent. So what we conclusion? OA means what? Radius. OA means what? Radius. And radius of a circle. OA means radius of a circle is perpendicular to tangent. Perpendicular to tangent. Where nanna? Where it is perpendicular? At A. At A they are the perpendicular at A. What is A? A is called point of contact. So that's why you can write at point of contact. I hope all are understood this nana. Here I can given information means I can take xy is the tangent to a circle with center O. At the point of contact A, join OA. OA is what? Radius. Suppose you can take any point on the tangent except A. All are located more distance from the center of the circle. That you I can write here. Therefore OA is the shortest distance. Where the shortest distance is there only formed the right angle. That's why OA is perpendicular to tangent xy. So radius of a circle is perpendicular to tangent at point of contact. Keep it in your mind. Now they ask a question as like this nana. Either 4 more questions. Prove that radius of a circle is perpendicular to the tangent at point of contact. Then you can write as like this. That is the answer. This is only the answer. Okay nana. Now the next point is number of tangents. See nana, suppose you can take a circle with the center O. Suppose here I can take a point P. Now what about the what is here point P with respect to the circle? External point. This is called external point. Suppose here I can take point Q. This is what nana? Internal point. Suppose here I can take a point here R. This is what nana? On the circle. So here some of the points outside of the circle, that points are called external points. Some of the points inside of the circle, that point is called internal points. Some of the points are on the circle. Okay, one of us, suppose here at P, sorry, this is R, at R. Okay, you can able to draw how many tangents at R? you can able to draw how many tangents? Only one tangent, yes or no? Only one tangent, so keep it in your mind. So then how many tangents you can draw to a circle from the point on a circle, then only one tangent. Suppose here I can take internal point q. From this q, here you can draw any line that is intersect the circle at 2 points, yes or no? Intersect the circle at 2 points. Okay, and if from the internal point we cannot able to draw the tangent, so that's why number of tangents is equal to 0. From an internal point the number of tangents is 0. So now what about that from external point? See, check it, nana. So here from this external point we can able to draw, there are, this is one tangent, yes or no? And this is also another tangent, yes or no? So here you can able to draw, there are two tangents, suppose here this tangent touches the circle here at a. Now suppose here this is the touches that circle at b. Here pa, pb, these are the two tangents. pa, pb are the two tangents. So from the external point we can able to draw the number of tangents is 2. What is that one? pa, pb. Here pa is called length of tangent. pa is called what, Anna? Length of tangent. pb is called also length of the tangent. pa is length of the tangent, pb is also the length of the tangent. This okay, Nana? Now once you see, Nana, this is the circle, the center is, I can take it is the center is O. Now here I can take the point P externally, okay, na, external point. Now the from this point you can able to draw how many tangents? Two tangents. Now here I can take the point of contact A. Now this is B. Now you know that what is PA? PA is called length of tangent. PB is also called the length of tangent. So here how many tangents you can able to draw from the external point? Two tangents. Now we want to prove PA and PB are equal. Okay, now we want to prove PA is equal to PB. These both are the equal. How we can prove that one? Suppose first you can write that given information. Given, okay, na? Given. What is given? Okay, na? This is the circle. P is the external point. So P is an external point to a circle with center O. Okay, Nana? Now PA comma PB are tangents to a circle at A and B. Okay, Nana? Yes or no? Now join OA and OB. Join OA OB. What about this OA OB? These both are radii. And OP. Now we can join OP also. Now we know that this radius, this is the radius perpendicular to the tangent, yes or no? Radius is perpendicular to the tangent. So therefore here we know that OA is perpendicular to PA and OB is also perpendicular to PB. Okay, Nana? I hope all are understood these points. Okay. OAP and another triangle is OBP. P. These two are the right angled triangles only. In these two right angled triangles, one angle is 90 degrees. See, angle OAP is 90 degrees. Angle OBP, this is also 90 degrees. Therefore, here the first point, angle OAP is equal to angle OBP, means it is that is equal to 90 degrees, means it is the right angle. This is the right angle. The next one, in this triangle, OP is the hypotenuse. OP is the hypotenuse. Yes or no? In this triangle, OP is the hypotenuse. Now, in this triangle, OBP, in this OBP triangle also, OP is the hypotenuse. So, OP is equal to OP. OP is equal to OP. This is a common hypotenuse. Common hypotenuse. Now compare these two triangles. OA is radius, OB is radius. Both are same. OA and OB, both are the common radius. Sorry, Nana, sorry, not common radius. Both are radius. That's why same. OA is equal to OB. That is on side. Okay, Nana. This side of the triangle. This is also side of the triangle. Both are the equal. Why? Because of these are radii. These are what, Nana? Radii. Same radii. That's why. Now here we can observe that right angle, hypotenuse, same side. So by RHS concurrency, by RHS congruency, by RHS congruency, triangle OAP is congruent to triangle OBP. Keep it in mind, triangle OAP is congruent to triangle OBP. Now, these two triangles are congruent triangles. These two triangles are congruent triangles. What is the meaning of congruent, Nana? Congruent means corresponding sides are equal, corresponding angles are equal. Corresponding sides are equal, corresponding angles are equal. Now here PA and PB are the corresponding sides. PA and PB are the corresponding sides. We know that corresponding sides are equal. Therefore, PA is equal to PB. Therefore, your conclusions, PA is equal to PB. This is one conclusion, important conclusion. PA is equal to PB. Why, Nana? Corresponding parts. These are the corresponding parts in corresponding triangles. See, PA and PB, these both are the equal. And also here, once you see here, this is one angle, the corresponding angle is here, the corresponding angle is here. These both angles are equal. These both angles are equal. Suppose this is X, this is also X. Okay, what about this angle? Angle POA. This is what? Angle POA. Angle POA. What about this angle? This angle is angle POB. See, POB. These both angles are equal. So that is the second one. Angle POA is equal to angle POB. Okay, Nana? Right. Now, the next one. See here. Now, once you see that this diagram here, once you see. Okay. Now, this is the corresponding angle of this one. Okay, na? These two angles also equal. What about this angle? Angle OPA is equal to angle BPO. So, angle, third conclusion, angle OPA is equal to angle OPA. B. These are three conclusions. I hope all are understood this one. Okay, Nana. See, this is a theorem very important, Nana. Okay. So, in priority 1, short answer questions. So, third question. Prove that the lengths of tangents drawn from an external point to a circular equal. And he asked that up to here only. Up to here. This is our answer to that question. Okay, Nana. Here we want to prove PA is equal to PB. First, write the given information. Then after, simple from these two triangles by RHS concurrency, these two triangles are the congruent. So corresponding parts are equal. So that's why PA is equal to PB. That's it only. Okay, Nana. Now, once you see the question, priority 1, short answer question 4. Prove that the tangents to a circle at the end point of a diameter are parallel. How we can prove that? Suppose, first of all, we can draw the diagram. So, this is the circle. This is center of the circle. Now, here, this is the diameter of the circle. This is the diameter of the circle. Suppose the diameter is AB. So how many endpoints of AB? Sorry, how many endpoints of this diameter? 2. That is A and B. Now here from A we can able to draw only one tangent. Suppose that name here can be it as PQ. Now at B we can able to draw another tangent. Suppose here named it as RS. Now the center of the circle is O. You know OA is or OB is our radius. Now first you write the given information. Given. What is the given information is here? Means AB is a diameter. AB is a diameter of the circle. With center O. Yes or no? Next, PQ and RS. What about this PQ and RS? PQ and RS are the tangents. At end points of diameter. End points of diameter. Okay, Nana? Side. Now we know that what do we know that radius is perpendicular to the tangent at point of contact. So therefore OA is perpendicular to PQ at A, point of contact A. Similarly OB is perpendicular to RS at B. Here OA is perpendicular to PQ, OB is perpendicular to RS. Perpendicular lines PQ, RS are perpendicular to AB. So perpendicular lines of one line always parallel. See, perpendicular lines to any line are always parallel. Here PQ perpendicular to AB, RS is also perpendicular to AB, and so perpendicular lines to any line are always parallel. Therefore PQ parallel to RS. PQ is parallel to RS. That is only our question. Prove that the tangents to a circle at the end points of the diameter are parallel. Yes, the two lines are the parallel. Okay, Nana?